Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for merging two sorted arrays. Let's look at the problem description. We are given two sorted integer arrays and then two integers m and n, which represents the number of elements present in those two arrays. We have to merge those two arrays into a single array sorted in non-decreasing order. We do not have to return the merged array. There is a space already allocated in nums1 array to accommodate the elements of the second array. In the example 1, the nums1 array has space for 6 integers and then out of which 3 are empty. The number of empty entries in the first array is equal to the size of the second array. Hence, we do not have to allocate a space for merging these two arrays. Let's take a look at the example 1. So the nums1 array has a space for 6 integers, out of which 3 entries are occupied already, and so that's why m is 3, and nums2 has 3 elements, so n is 3. So basically we maintain right index pointing the end of the nums1 array's allocated space, and the read index points to the current last element. The read index 2 points to the last element of nums2 array, and so basically we compare the elements pointed by read index 1 and 2, and then whichever is greater we write that in the entry pointed by right index. So 6 is bigger, so we write the 6 in the last entry and then decrement the read index 2. Let's look at the flowchart for this solution. Input for this procedure is nums1 and nums2 array and then m and n integers, and then we first initialize the read and write indexes. The right index points to the last entry of the allocated space of nums1 array, and the read index 1 points to the last element currently stored in the nums1 array, and read index 2 points to the last element in the nums2 array. First we check whether one of the array is completely processed. If yes, we break out of the loop. Otherwise, we compare the two elements pointed by read index 1 and read index 2 and check which is greater. If the data pointed by read index 1 is greater, then we write that data into the entry pointed by right index, and then we decrement the read index 1. Otherwise, we decrement the read index 2 and write the appropriate value in the right index. Then finally we decrement the right index and continue the loop. After coming out of that loop, we have to process the remaining elements in one of the array. If the nums1 array has some element, then we read those elements and then write it into the final position, and then we decrement the read index 1 and write index. We do the same thing for the nums2 array. If there are any leftover elements, we copy them, and then once that is done, then we come out and we return. Let's move on to the coding part. First I initialize the right index so that it points to the end of the allocated space of nums1 array. Then initializing the read one index so that it points to the last used entry in the nums1 array, and then initializing the read index 2 so that it points to the end of the second array. So inside this for loop I am comparing the elements pointed by the read index 1 and 2. If the data pointed by read index 1 is greater, then I am writing that into the entry pointed by right index. Otherwise I write the data pointed by the read index 2. After writing the data, I'm updating the read index 1 and read index 2 depending on the condition. Then write index also needs to be updated so that it points to the next locations where we can write the next smallest element. So in this for loop, I am copying the remaining elements in the nums1 array. This second loop will copy the remaining elements in nums2 array to nums1 array. Finally, the nums1 array contains the merged arrays. Now I am going to run the program. Oops, there is some compilation error. Okay, let me fix that. Okay, I rerun that. Okay, now it is accepted. And second case passed, accepted. Third one also accepted. Okay, good. Now I am going to submit this program. Cool, it's accepted. Let's do the code walkthrough with sample input. Let's do the code walkthrough with this input. So the first for loop compare the elements pointed by read index 1 and read index 2 and write the larger value in the entry pointed by write index. So in the first for loop, the numbers pointed by read index 1 and read index 2 are compared. If read index 1 is bigger, then we write the data into the entry pointed by write index. 3 and 6 are compared, and then the 6 is returned into the entry pointed by write index, and then the write index and read index 2 are decremented. Next 3 and 5 are compared, and 5 will be written in the entry pointed by write index, and then the read index 2 will be updated, write index also. Then we compare 2 and 3, and we write the number 3 in the write index, and then the read index 1 will be decremented. Now number 2 and 2 are compared, and then we will write number 2 in the entry pointed by write index and decrement the read index 1. Then we compare 1 and 2, and the 2 is greater, so then we update the entry pointed by write index with 2, and then we decrement the read index 2. Now we completely process the nums2 array and we come out of the loop, and now we check whether any outstanding element in num1 array. We have one element, so we copy that element in that entry. There are no more elements in nums2 array. We are come out of that loop, and finally the nums1 array has all the merged data. Next we will see the time and space complexity of this solution. Let's take this input for our analysis. So for this input, do 5 comparison and assignment operation, and then there is one element pending in the nums1 array, so that loop will run once. So totally 6 assignment operations are done. For the case 2, the nums2 array's elements are all greater than the elements present in the nums1 array. In this case, all the nums2 array's elements are occupying the empty slots in the nums1 array. So the first for loop run only 3 times. Then there are no other elements needs to be processed. So if there are no elements in nums2 array, we can return early, as the elements in nums1 array is already in a sorted order. In the case 2, only 3 comparison and assignment operation is done. So the total number of times the first for loop runs is ranging from minimum of m comma n to m plus n minus 1. The overall time complexity is order of m plus n. So with respect to the space complexity, it is order of 1 because we are not allocating any additional space for this merging operation. Thanks for watching this video. Have a great day.